Assalamualaikum warahmatullahi wabarakatuh. My name is Lina Haina binti Zambushah and I will be presenting my group on our IDP presentation about our project, the Automatic Surface Water Pump with Water Sensor. This is the introduction that briefly describes on what problem that we are solving. The newspaper article from Sinar Harian in November 2018 on how the collapse of reservoir affects the small-scale maize farmers. Due to heavy rain, the reservoir tends to collapse because the water overloads. To specify more on our problem, we engaged with a 55 years old durian farmer, Cik Ismail bin Cik Leh, who operates a durian farm in Pasir Putih, Kelantan. Based on Cik Ismail, the overloading of water in the reservoir occurred due to heavy rain, especially during the monsoon season at the end of the year in East Coast region. Every time the reservoir collapses, he will have to rebuild it again. And based on Cik Ismail, he said that he is currently using mechanical water pump to pump out the excess water to the nearest creek that is around 15 meters from the reservoir that he built. The usage of mechanical pump, which currently used by Cik Ismail now, have few disadvantages such as it produces noise, pollution, and it needed to be operated manually. What drove us to solve this problem is most farmers still use conventional water pump where it requires human energy to work. Therefore, considering that we are already in 2021, we think that it is about time for us to design a solution that minimizes human work, especially involving elderly farmers in rural areas. Also, when collapse happens, it will be a burden for the farmers to rebuild the reservoir again. The method of using conventional water pump, which requires fuel or to operate, also is not sustainable. This is like one of our efforts to make agriculture sector more sustainable. Instead of relying on fossil fuel to generate power, we substitute it to a solution that are more sustainable and reduce harmful emissions. Our target user for this solution is small-scale farmers as Cik Ismail, who have low operating budget, limited access to technology, and relies mostly on human energy and ability to supervise the reservoir. The impact that the reservoir collapsing to the farmer is it will cost farmers a lot to rebuild and also time. The plantation will also be affected, which will of course makes the farmers will face loss, and the farmers need to manually monitor the water level. Benchmarking has been done. We found that the most commonly used with rural farmers are mechanical water pump and pond riser. Mechanical water pump, of course, the most used one in Malaysia. It is able to pump the excessive water in the reservoir. However, it is expensive and it requires fuel to operate. For pond riser, it is able to control the flow of water in the reservoir. It is low cost, but it is still not really reliable as the user has to check the water level manually. The attributes that we want our solution to have is our solution must be able to pump out the excess water, our solution must be able to work automatically, our solution also must be able to sense the water level before the water overloads. As we identified what our user needs are, we have tabulated our design numbers with the list of attributes as shown. More importantly, our design solution must cost less than 1,500 ringgit so that it is considered affordable for small-scale farmers. This is the sketch of our solution and its components. We have pump, water level sensor, microcontroller programming, solar panel, battery, maximum power tracker, and pipe. How our solution works? Our solution have three subsystems: solar panel, microcontroller, and water level sensor, and water pump. And then subsystem 1, the first subsystem is the power generation from the solar panel, while the subsystem number 2 is the detecting mechanism and microcontroller programming. Subsystem number 3 is the process of pumping the water out of the reservoir. This is our design analysis and validation. This is our design number on what we would like to achieve with our solution. And the ability to pump the water, this is the dimension on Cik Ismail's farm. We calculated the volume of the reservoir and the 10% from that volume. The height, the 10% height is the height that we want our sensor be able to detect. We choose the optimal diameter pipe and flow rate based on the graph as shown in the screen. We obtain the friction factor as well. We did a simulation on SS Fluent for the 2D velocity flow-in pipe to validate the diameter chosen for our pipe. The diameter chosen is like 1.5 inch, which is equal to 0.0381 meter. Based on our flow rate, we calculated the total head of the pump and found that our design pump is able to move the liquid up to 76.98 meter as required by Cik Ismail. In Cik Ismail's case, he requires the water to flow around 15 meter to 20 meter. Therefore, based on our calculation, our design pump are able to do that. By substituting the value into the formula, we obtain that the pump will require 180.98 watt of power to operate. Therefore, we have to generate that much power in order to operate the pump. For our sensing mechanism, we constructed an electronic circuit with a microcontroller and sensor unit using Arduino and developed a code to operate it. For power generation, the solar panel will be purchased and a power tracking is also used to enhance the performance of PV module. But due to the timing and cost constraint, we are unable to simulate this subsystem. However, by using MATLAB and Simulink, we analyze the performance of the PV system with and without MPPT. So considering that we want our solution to work in a rainy and monsoon season, the MPPT are much needed since MPPT are proven to improve the efficiency by 35%. Improve the efficiency of the PV solar system. Since we are performing simulation, we are unable to determine exactly how much our solution will cost. But from a bit of our research, this is the estimated range of price for our solution components list. The total calculated is around 1,340 ringgit, and it is still within our budget for this project. The value that our solution brings is that it reduces workload, and the user are now worry-free since the pumping system is now automated. It is also reliable as the sensing mechanism helps in detecting more accurate water level compared to human naked eyes. Lastly, in our mission to strive for a more healthy world, we provide a solution which relies on the solar energy instead of fuels. In a long run, we believe that it will cost lesser compared to the fuel water pump. A solar powered water pump are not really normalized yet in Malaysia. Therefore, we hope that our solution are able to create the familiarity while providing a more affordable way to operate the farm. That's all for me. Thank you so much for your attention, and we hope to receive constructive opinion from you. Thank you very much.